Okay. In Gamala the young people want to farm a 10-acre plot of land. The problems with this are there's no current irrigation system, the water is 2 kilometers away, and there's a scarcity of energy. Our mission was to create a system to pump water to the farm using solar power. Through our research, we found that the system needed to be durable and goat-proof. It needed to be easy to use and easy to repair, and it needed to, I don't remember. And that's
For this project, we had 4 ideas. We came up with an aqueduct system, a underground piping system from the lake to the farm. We came up with a canal system that ran from the lake to the farm as well. And then we had a fire hose run along the top of the ground from the lake to the farm. And we decided to go with the aqueduct system because of safety concerns with the canal system, the underground piping, and the fire hose due to anything that could happen to them and maintenance issues and expensive materials. Here we have our aqueduct system. This CAD drawing shows the dimensions of the actual aqueduct system itself. It runs 2,000 meters long, it's 12 meters high, and it's about half a meter wide to run water the length of the distance. Down here we have the display showing the solar panel, the pump, and how it pumps up the aqueduct. And then at the end of the aqueduct, we have it showing how it feeds into the sprinkler system to run across the 10 acres that we have. And then for our bill of materials, the total cost of the prototype was $40. As stated right here, we had a pump, the timer, PVC piping, the moisture gauge, 2x4s, soil, and the connectors for the PVC.
For our testing, we did 3 different tests. The first test was just the pump to the pipes, straight to the soil. There was no dispersing of the water or anything, and we found there was some problems with that, so we designed a second test where we installed a sprinkler system as shown here, so that disperses the water evenly. Our third test was testing how fast our pump pumps water out at its lowest setting, and we found that it was around 120 gallons per hour. Okay, so for our aqueduct system, we have a fountain pump down in the bottom of the bucket. It pumps the water up the pipe into these sprinklers, where it sprinkles the water around the whole entire farm. This is a scaled down version. It's 1 foot by 1 foot, and then it pumps all the extra water that doesn't spray out of the sprinklers back into the bucket so that we don't waste as much water. Then we have this water gauge that tells us how wet the dirt is, and that's how we tested it.
Alright, based on the test, we had the testing result. For the first prototype, since there's no sprinkler system, the water just disperses in one area. Thus, there's dry spots in the space which we do not want. For the second one, since we put the sprinkler system, the water spreads more evenly, which is what we want as a result. Thus, in conclusion, because of that result, we choose the second prototype as our final product to be shared with people who want to